Hello and welcome to our webinar on the new MaxAva data protection software solutions for your critical IBM I power systems. We hope that you will see why thousands of customers, partners, and service providers around the world have chosen MaxAva to assure their mission-critical applications for the past 18 years. This 15-minute video is designed to introduce the core elements of the MaxAva software architecture and highlight how our solutions work together in unison to proactively protect your data from any disaster scenario. And please keep in mind that you may always find other short educational videos or request a deep dive demonstration regarding anything you see today over at our website, maxava.com. With that said, I'd like to turn things over to today's technical presenter, Martin Norman.
Thank you, John. Here we see the contents of my price file on the main production system. We can see that each product in that price file has a cost associated with it. $1, $2, $3, $4, etc. On the backup server that contains a cloned replica of the same file, we see that same data. You'll see that I've used a purple color on the screen here to represent that backup server. Jumping back to my production system, I'm going to use my user profile to run a program which doubles the price and doubles the costs of those values in the price file. On completion of the program, looking back at the price file, we can see that all of those costs have doubled. Because the MaxAva HA software has been defined to replicate data from my production system to this backup system, we can see that those data changes have arrived on the backup server as well. That is HA working in exactly the way it should. You now have protection, so in case there is a disaster of some sort on the main production system, you can fail over to your backup server. But sometimes things don't go according to plan. Here we see 2 more sessions logged onto the production system for 2 of my developers. You'll see the username dev1 and dev2 being used. I will focus on the dev1 user profile first, and it's going to run a command to perform that double processing 10 times. So it's a script, part of the MaxAva software, to run that program 10 times. Unfortunately, the developer thought they were in their testing environment, but in fact they're not. So what's going to happen here is it's going to double the costs in all of the price file, the main price file, and not in their test data. As this script runs, we will see the doubling of the cost field happening. We see that first record for the knife increased to 4, then on to 8, and on to 16, and that continues until eventually the program ends. Here we can see the last value before the program ends. Jumping across to the backup server, we can see the effect of what happened there when the programmer ran the program across the wrong file in the wrong library. We can see all of those effectively corrupted values on the backup server. The HA software has done its job. Changes were made to the price file that was defined as being replicated to the backup server, and that's what's happened. All of that data change has come across and now exists there. Other problems can occur as well. Returning back to the 2 developer sessions, I'm now using developer 2, and they're going to delete the price file because they're finishing their testing that they've been doing on their price file. But unfortunately, they don't notice it's the main demonstration library file that's being deleted, and they're going to delete the wrong object. Here the developer can see the result of what they've done. They thought they were deleting the price file from their own personal library, but it's actually come from the main library and it's now been deleted. Returning to the backup server, running that same command again, we can see that that price file is no longer there. The one we were looking at earlier has gone. My example here is not a hugely volatile file. We've seen some changes to it, but if you imagine this was maybe an order file receiving updates every second, maybe changes to dispatches, maybe new orders coming in from the internet, maybe new orders coming in from a connected server. All of those changes happen regularly, and if the file gets deleted, no matter how recent your backup was, you'll have lost transactions. But fortunately, these systems have the Maxava CPR product installed and configured. It will act like a recycle bin, allowing you to recover from disasters such as this. We'll be using a special restore location. We can see at the top there, library name is CPR restore. At the moment we can see this library is empty. It will be used later on in the demonstration. Here we have the Maxava CPR GUI. For those of you familiar with the Maxava HA software, you will see the look and feel is very similar. CPR holds a registry, which is a list of all the special archives that it has performed. The latest archive, shown at the top of the registry, identifies that we noticed, and CPR noticed, the actions on that price file. As we know that that price file was deleted in error, we're going to perform an action to perform a restore. We can see details of the archive, including where it's located. I've actually stored it in the IFS on the IBM I partition, and some details of when it was added to the store. The bottom of the window, I've decided to restore it into my special restore library, and I'm going to click OK and complete that. Returning back to the backup server, we can see that there is now one object, one file in that special restore library, and it's that price file. Looking at the contents of that file, we can see it's now back. But as we noticed before, there's a lot of corruption there because developer 1 had run the command to double the price, the cost fields 10 times. And those corruptions are still a problem to us. CPR provides a way to restore back to a critical point too. I can use either the GUI or even the green screen commands to do this. So here on the screen, I'm telling CPR to roll back all the data changes that were performed by developer 1. On completion of the rollback, we can see that the price file is back in the correct state. It has the prices, the costs all doubled as in the first time when the program was run to do that price update. To summarize, CPR can watch for critical delete and clear events, and before those requests are actioned, it will archive that latest version of the object either locally or onto a remote server. For flexibility, CPR can also archive based on scheduler entries or by executing an API through your processes. Critical actions such as this need to be supported by strong monitoring and alerting. For example, you could use the Maxava MI8 monitor to show you what has happened within CPR. This cloud-centric product can be accessed by browsers, as we see here, Apple apps, and also can be configured to send selected alerts out as external notifications, such as emails or text messages. There are many views available in MI8, both table-based or graphical. For example, this summary view, which is telling me about the 4 systems that I'm authorized to monitor, and that one of them currently has a problem. On this more detailed view, we can see that CPR on my backup system has raised informational alerts that the price file was restored and even that a rollback was performed. In addition, MI8 can monitor what's happening inside the HA software as well. For example, at the top there's a red icon that's telling me that there's something currently wrong with the configuration of my QDLS replication. So we can see the power of MI8 for watching critical things happening on that backup server. However, it can also be tuned to watch for other system areas and application areas such as disk, performance, application messages, and even security breaches. We could sit around waiting for things to go wrong with my production system, US Demo 3. However, I'm going to kickstart some of those by running a command on the IBM I. This script will do exactly that. It will make some things go wrong and they will start to appear within MI8. So we can see some of those alerts starting to appear against US Demo 3, my production system, on the left-hand side. I've got messages coming from a message queue, such as unable to process ERP month end. I have another message coming from the ERP system that's waiting for a response. It's an inquiry message on the IBM I. And at the bottom of the screen, a message about a subsystem, which is my nighttime subsystem, which should not be active during the day, but someone has started it. Alerts continue to appear. I have a message about my daytime subsystem, which someone has ended. I have a yellow icon there, which is a warning level to show me that the number of active jobs on this system is creeping up. MI8 also provides automation tools. For example, with the alert about the subsystem MM8 demo day going inactive, we can also try and restart that automatically in the background. That is what has occurred here. It's changed now to blue, and in the next few seconds it will also change over to disappear totally. There it goes, and it has been removed from the screen. As I mentioned before, we can also push messages out as emails or text messages. So here we can see a view of my cell phone with some of those messages appearing there. This is a two-way process though. You can see at the bottom of the screen in green 2 of the responses that I have provided for those alerts that were sent to my phone. The first of those is using a pin 6780, is a retry message that's being sent back to the inquiry message that came from the IBM I. So I don't have to go back to the green screen, I don't have to start up a VPN, I can just send my reply from the phone. Below that, I have another instruction being sent back from my phone to the IBM I, again using a pin to uniquely identify the phone and this conversation, and it's going to run a command to end the nighttime subsystem. Those commands will be received by the IBM I, and the various views within MI8 will change. As we can see there in the background, the messages have changed again, have disappeared. As was mentioned earlier, we can also forward those alerts, maybe the more critical alerts, as email as well. So here we can see an email containing a couple of those messages, one about the cancel retry message and one about the nighttime subsystem being in the wrong state. On my phone, I've now opened the app, so we can see the browser session, the app session within there, and I can see the same information about my Demo 3 box and my Demo 4 box. So by a combination of automation, remote responses from the phone, and issues naturally resolving themselves, the MI8 display for the production server has returned more towards a steady state. The 3 informational alerts which I have here need to be removed manually and they need to be acknowledged, so the administrator is saying, yes, I've seen these and we've reacted to them. To do this, I could go to one of the more table-based view, and we have an option there to acknowledge all events, which I'm doing here. And this is where we're aiming to get to all of my 4 systems back to a healthy and stable and calm state with no errors. So to summarize, we've used the high availability software from Maxava to provide that failover protection by replicating data changes and other objects from the production server to a backup server. We've used CPR to provide intelligent data capture, looking for the most critical actions on the most critical objects, and even providing a rollback if we find that things are changed in error. And on top of all that, the MI8 monitoring software, which allows you to watch for the critical things, alert the right people at the right time, wherever they are.
Thank you for watching this demonstration. For further information, please contact Maxava or one of our partners.